South Africa, a country where necessities are a challenge and reality in poor communities. Awqaf SA is on a drive to make a positive change in people's lives. Our work is deeply rooted in the ethos, history and belief of our religion. Through your Awqaf donations, we are building a brighter future for education, healthcare and infrastructure, and fulfill a sunnah in paving a way towards a brighter tomorrow. With your support, Awqaf SA has the power to transform lives for generations to come. Donate today and build a foundation for a brighter tomorrow. Awqaf SA, creating an eternal legacy of hope and dignity.
Sigeleli Africa, Manupaganyisu Pondolwayo, Izwa imitandazo yethu, Nkosi sigelela athina lusapho lwayo. Murena buluka sichaba sa Yesu, ufedise dintwali matwenye, usibuluke, usibuluke, sichaba sa Yesu, sichaba sa South Africa, South Africa, Ediplofa no seyem, Editipte fanonsie, Woronsie vetrebet, Van die Klasse antwortet. Sounds a call to come together, and united we shall stand. Let us live and strive for freedom in South Africa.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff. Liftoff. 30 minutes after the
Good morning, goeiemorgen, sawubona, namaste, assalamu alaikum wa rahmatullahi wa barakatuh, and a warm welcome to one and all. We are coming to you live from Spine Road High School here in Mitchells Plain. I would like to request a warm applause from all learners here in attendance. And infrastructure development. Next year, we will be celebrating 10 years of hosting this maths intervention that aims to prepare learners for the maths examination. We have Mr. Kota, he'll be the facilitator, but without
مستقيم صراط الذين أنعمت عليهم genocide that is facing them. We thank you, most beloved, merciful Lord, and pray that our humble supplications will be accepted. Thank you. You may be seated. I would like to take this opportunity on behalf of the Spine Road management and staff to welcome all of you here to this beautiful session. We are indebted to Awqaf South Africa of this opportunity. I hope and pray that after this session, you will enter your classes reinvigorated, rejuvenated, and ready to spring further into your term.
We call on Mr. Ronald. He'll address us before we get the session on the go. Yeah.
Thank you, Hassan. Good morning, students. I'm almost giddy. I'm so excited. You won't believe it. I think this is probably a good long time. In fact, for those of you who know Mr. Levitt, he was in a similar session like this. So potentially, you could be a Mr. Levitt tomorrow. And on behalf of the district management, I want to thank the Awqaf organization. I want to thank Spine Road for allowing this to happen. And with that, I want
Mr. Kota, the maths facilitator. He has been the facilitator of this program since inception. Like I said, we will be celebrating next year 10 years of hosting this intervention. It is in preparation or a means to assist learners with a maths examination preparation. Maths is a very important we will also be giving you some comfort breaks. I'm going to hand over the mic to Mr. Kota. He'll just brief us very quickly just to warm up the session. Give me your wildest round of applause for Mr. Kota.
a bottleneck. We are days away from your prelim exams, and blink again and we will be in our final exams. Our aim this weekend is to show you and to teach you all the systems and processes. Like Mr. Levert that's here, that was at Mondale, he attended our workshops in 2011, scored a distinction in math, and today is a math and getting learners 100% in mathematics. Guys, anything is possible. Anything is possible. We've had learners from below 40 and 50% that scored 90, 95, and 100% after the program. Learning the systems, knowing what to do, knowing the tools, the modus operandi of mathematics, and once you got the tools, the application of the tools. Now remember, this is not the last program for 2025. This is the prelim one to wake you up, skrik you wakker. The big one at the end of the year as well, where we'll be taking a whole lot of past papers from national and we'll be working through them. What I've done and the program for today, just waiting for those learners to settle down on that side. This is the way it's going to work today. Today, paper 1, tomorrow, paper 2. We have started a little bit late due to all the formalities. We will finish off at 3 p.m., but we will have breaks in between. Guys, we're going to start with algebra and inverse functions. We'll then take a break. We'll come back. We'll do calculus, the big topic. Item for item, topic for topic, we're going to go through the entire syllabus to ensure that you are fully geared by the time. We are one family. This is the large And then for today, right, after your algebra, after you've mastered your algebra and got your full marks there, you know you need to know your sequences and series. After your sequences and series, your functions. All your functions and your inverses. If you want to take this down, and 50 for paper 1. We're doing paper 2 tomorrow, or whatever we don't complete from paper 1 today. I think that it will only be one topic. Before you know it, I know it looks like a long time, but before you know it, today is over. Paper 2 tomorrow. You know what you need to know you need to know analytics from grade 11, circle analytics, trig, data has regression, Logarithmic curve, standard deviation and variance, and Euclidean. That is the structure of your paper. Can we get the screen up? I just need the whiteboard up. I need the whiteboard up. Okay. Our program is, I'm just waiting for the whiteboard to come up so that we can get started. How do we know when something is convergent? You look at R. R is a fraction, it's convergent. R being a whole number, it's divergent. Very good. We're going to go through all of this. As soon as the whiteboard comes up, we're going to be going through the whole mind map. For convergent, what's your formula? S to infinity equals A over 1 minus R. And for divergent, S to infinity equals hyperbola with a shift in asymptotes. Exponential. Exponential with a shift in asymptotes. And obviously your grade 12 graph, which is your log graph. Yes or no? Lovely. What do we need to know for each one of them? We need to know how to sketch, find equations, domain, range, turning point, amplitude, minimum and maximum values. Where is the one graph greater than the other, less than the other, multiplied by the other? Asymptotes, equations of axis of symmetry. That is your functions, all your inverse functions as well. Then we have calculus, first principles, your opening question. There we're just walking, we're mentally walking through your prelim paper. First question, so you know your structure. I'm familiarizing you with the structure of the paper. First question, first principles, f dash x. F dash x is equal to, what we all know it, the limit as h tends to 0, f of x plus h minus f of x all over h. Yes or no? Good. Then you got derivative, the power rule. Power times coefficient minus 1 from power for each term. Then you've got differentiation for more advanced equations. Finding the equation of tangents to a graph at a point. One where you've got to find the tangent and one where the tangent is given and we've got to work backwards to find A and B. Then we need the graph, the cubic graph. The cubic graph, how to sketch, how to find equations when your turning points or stationary points are given. We need to make sure we know that. One where the derivative graph is given and you need to find its equation. Then we have what we call optimization. I know you guys cry with optimization, but we've got shortcuts, we got hacks. It's easy. Optimization is only a formula. You plug into your formula, find the derivative, put it back into the original, and you get your final answer. 3 types of optimization. The first type of optimization, volume and total surface area. The second type of optimization, the graph. The third type, volume acceleration. Velocity acceleration. Yes or no? Right. Then we have finance. Future value, present value. Annuities. Again, I'll give you a mind map. I'll give you a mind map and we'll do one of each type to get you familiar with it. Sinking funds, loans, balance outstanding on a loan, the trade. Am I talking Japanese here, guys? No. You're following me, right? Balance outstanding on a loan, the trade-in of an asset, immediate payment, deferred payment, final payment. That is your entire financial component. Then we got probability. We've got probability, factorials and fundamental counting principle. You need to know the major difference between the two. I'll explain it to you when we get to it. We'll go through the templates. We'll go through all the examples. Factorials, how many different types, in how many ways can 10 people be seated in a row? If people were grouped, in how many ways can they be put? Those are factorials. You also got to know your grade 11 probability, mutually exclusive events, independent events, tree diagrams, two-way contingency tables, independent and mutually exclusive events. And that is the entire, we've just wrapped up, we've walked through paper 1. Let's walk through paper 2. Paper 2 is your analytics. Grade 11 analytics, the only thing that has been added is your angle of inclination. But it's all your grade 11. You're going to get 2 questions. 20 marks, 20 marks. Then you've got circle analytics for another 20 marks. Finding the equation of a circle whose center is not at the origin. Then we've got trigonometry, reduction, identities, simplifying, substitution. If sine 21 equal k, find cos 21 in terms of k. Identities, proving left hand side equal to right hand side, double and compound angles. Then what do we have? General solution, the one that kills you guys. Ah, come on, that's so much of fun. 7 marks. It's marks for Mahala. Mahala marks. You got trig graphs, your sine graph, your cos graph, your tan graph. You got 2D trigs or 3D trigs. Area rule. What's our area rule? Half of a side times sine of the included angle. Yes or no? The sine rule. A over sine A equals B over sine B. Yes or no? Cos rule. A squared equals B squared plus C squared minus 2BC cos A. That will give you another 30 to 40 marks in trigonometry. Stats, mean, median, mode, modal class, standard deviation, variance. You did a new topic this year, only one new topic, regression. Show of hands, how many of you have done regression at school this year? Nice. Regression, the equation, the line of best fit. Yes or no? The scatter plot. And then we've got Euclidean. Grade 11. Don't stress with Euclidean, guys. 50 marks, Euclidean. Give me a second. Must I present? Share screen? I did. There's it. Okay. Don't stress about your Euclidean, guys. Don't stress about your Euclidean. Half of your Euclidean is grade 11 work. You need to know the proof of your circles, line drawn from center of circle to midpoint of a chord. Tan chord theorem. Angle at center, exterior angle at center is 2 times angle at circumference. Tan chord theorem, make sure you know it. You're going to get one problem on Pythagoras. You're going to get some easy grade 11 riders, and you're going to get 1 or 2 challenging ones which are not too bad. That will be at least 30 to 32 marks. So that's guaranteed already out of 50. The last part of it will be your similarity and proportionality. Proportionality, you've got to know the proof of the theorem. That's marks for free. You're going to need to know easy proportionality, maybe one higher order proportionality, then easy similarity, and one question that's higher order at the back. And there we go. We've just walked through your entire paper 1 and your entire paper 2. So guys, Don't panic. Let's wait for the whiteboard or the Jamboard to come up here from our tech department. And let's get fired up. Hasanain, how are we looking there, bro? The minute the whiteboard comes up, we get fired up.
Learners, we are almost resolved the issue with the internet connection. We will be sorting that out now. If we can just request one thing, if any of the learners from the Spine Road High School, if you are on the Wi-Fi, if you can just disengage your phone from the Wi-Fi connection, it will help our upstream a little bit in terms of using that connection. We are almost, we have almost resolved this issue. Just bear with us. We will be up. Our technicians are working the issue. So we will be having, lunch today. We will be serving you lunch today. So this is where we deal with Maths Paper 1 today, and we will be doing Maths Paper 2. Thank you for your patience. We just need 5 minutes of your time. In the meantime, you can just bear with us and we will resume shortly. Thank you so much.
He doesn't have a network connect point, bruh.
What's your his point there, maybe, but then he plugs it into his PC and then we
Where's his thingy? That thingy that gives him what's the name? Okay, hold on. You see his screen now?
That's right. Check.
Let's see if you see him now.
Also spoke too much Wi-Fi. I'm going to also try and see what they get.
Now,
His whiteboard, that's on it.
how do you share the whiteboard, Hassan? Because now we got the internet is good. We could.
Let me help you here. So you do that. But where's the whiteboard now? The whiteboard disappeared.
The window.
Okay. Yeah.
See if someone sees that thing there. That other one be off. You use that thing, top one. Then remove the camera.
No, you can't remove it. Ebs, I hope that you come through for me, my man.
That's it.
Oh, you're in venue. There's 13,000 learners on YouTube, but there's 700 learners in person.
Doesn't show his screen.
No, they can come through.
Hold on. I'm trying to reshare.
So it's essentially to run my YouTube thing. I just need some. Yeah. But can't they come like urgent
Adding,
because
adding,
maybe like a
adding, adding.
walk out here? It's like it's a disaster. Okay, no problem.
Yeah.
It's too much Wi-Fi.
Okay, we good. We good. We have a screen.
Right. What's happening, sir?
Very good.
Okay. And we are back. Learners, can I get your attention? We are back online. Thank you so much for your patience. We will be resuming with the session. We do have Mr. Kota's whiteboard. Mr. Kota, take the show away. In the meantime, some of you have been having some of your refreshments and snacks. We will be resuming. Mr. Kota, take the show away. There we go. Mr. Kota's whiteboard is up. Thank you for your patience.
Thank you, thank you, thank you, thank you, thank you. Right, boys and girls, we're about to get the session going. Get to your seat, take your seats. Let's get the show off the ground. Now, let's start off with the algebra, guys. I'm not going to go through the quadratic formula with you, but some of the questions, let's open up with a question that looks like this. If I told you 9x minus 2 into 2 minus 3x greater than or equal to 0. Let's start off with this. Take this one down, guys. Take this one down. Now there's a challenge here. This is not your normal question, guys. This is not your normal because you got 2 minus 3x. It's not like if you had on this side, and this is the new style of them asking you the question. Normally, they would give you something like this, 3x minus 2 into, let's say, x minus 1, greater than or less than or equal to 0. This is the new style of question that is being asked, where they put the x behind and they make this a negative. So yes, guys, what we need to do is we need to find our two critical values, yes or no? So 9x minus 2, you guys can work on it already. 9x minus 2 equal to 0. So x will equal to 2 over 9. Or minus 3x will equal to, minus 3x will equal to minus 2. X will equal to 2 over 3. Now if we go to our calculators, give me a second. Take out your calculators. Work this out as a decimal. What is 2 over 9 and 2 over 3? Just work it out. Give me a second. Let me take out my calculator. Right, here we go. 2 over 9. 2 over 9. And we're going to get as a decimal 0,2. 2 over 3, we all know is 0,666, which is equal to 0,67. Now, be careful. Be careful. Draw your parabola. Draw your parabola. What's the name? I've got a bit of a lag there on the screen. Okay. Put your lower number first. Put your lower number first, 0,2. Put your higher number second, 0,6. Lower number first, higher number second. Greater than or equal to 0 is where is this above your x-axis? So where is this graph above? It's above there. So put your x between the 2 points. So you're going to have x less than or equal to 0,6 but greater than or equal to 0,2. This is the new style of question where they gave you the x, a negative value at the back. I'll do another one like this for you. Let's do one more. What if I told you 2 minus x, x plus 6, less than or equal to 0? Let's do this one again together. So your critical values is going to be minus x plus 2 equal to 0, minus x will equal to minus 2, x will equal to 2. These are your CEVs. On this side, you're going to have x plus 6 equal to 0, x is equal to minus 6. I'm going to put a tick here on both sides. I think we all know what we've done. It's a negative parabola because x is at the back and it's negative. So we got the lower number first. We've got the higher number second. What does less than or equal to 0 represent? Below or above? I can't hear you. Below or above? Below. So where is this below? It's below there and it's below there. So x greater than or equal to 2 or x to the left less than or equal to minus 6. There we go. Done. We all good? Lovely. Watch the next one. Let's do one or two higher order ones with regard to inequalities. What if I told you x minus 6 over x plus 4 less than or equal to 0? Let's go there. Let's go there. Try it. Then I'm going to take out 1 year from the past paper, the June exam, Gauteng June exam paper, and we're going to do it all together. Now watch how easy is this. I know many of you battle with this one here if it's a fraction. Watch what happens here. What are your critical values? Plus 6, minus 4. Yes or no? Now watch here. Watch here. It's a positive because the x's are positive. So all you do that. You do that. It's a positive parabola. Lower number first, higher number second. Less than or equal to 0 means below. Where is this graph below? It's below there. So put an x there. Yes or no? Now watch here. X, 6, minus 4. Use the same signs. But be careful. Can x equal to minus 4? Guys, can x equal to minus 4? No. Why? Minus 4 plus 4 will be 0. Can we have 0 in the denominator? So x can't equal to minus 4. So next to minus 4, just remove the 1 equal to sign. There's your final answer. It's shortcut. You can do it in one step. You can do it in one step. Learn this. Learn. Okay. What happens if you get 3 values in an inequality that's going to be used in calculus? What happens if you get 3 x values? So what if I told you x minus 6, x plus 2, x minus 4 less than or equal to 0? Solve for x. three x values. I'm going to show you another. Please learn this, guys. Every time I show you a problem, I'm going to be showing you the shortest, quickest possible way for you to get to your answer. No long drawn affairs. Quick, get your answer and move on. Right, watch here. What are my critical values here? Plus 6, minus 2, plus 4. Yes or no? Now watch here. All we do, it's 3x values. So all we do is we draw a cubic graph. 3x values is a cube. Lowest, minus 2, 4, and 6. I'm going to put a tick there. You all okay with this, grade 12s? Beautiful. So far, so good? Thumbs up? Understanding? Lovely. Now watch. Less than 0 means what? Below. Where is this graph below your x-axis? It's below there, and it's below there. Yes or no? So put an x here and put an x there. That's it. Don't use a table. Don't use a number line. Don't use anything. You just do what I'm doing. I promise you, you won't go wrong. Now you copy and paste. X, X, 6, 6, 4, 4, less than. It's between the 2 points. Or it's all your x values to the left. X less than or equal to minus 2. There we go. Final answer. Easy, right? Easy, right? Let's give you one more to do like this. In fact, I'm going to give you two. One with 2 x values from a paper. From a prelim paper, I'm going to give you one to do, and I'm going to give you one with 3 x values. Let's see if you guys can do both. Can I clear the frame? Has everybody taken this one down? Lovely. Watch this. Right, so let's do. I'm making it up. So let's go here. Let's put a line down here. On this side, let's give you the one from the paper. X minus 2 all squared greater than or equal to 1 for 4 marks. Okay, and the next one, let's do this one. X minus 3, x plus 1, x minus 2 greater than or equal to 0. So here we go. We got 2 to do. I think we're into the program now. We've settled nicely. Everything's moving. Thank you, guys. We're good to go. Talk to our onliners there. How's our guys from across the country? Relax. We got a 2-day program. Action-packed bumper session for 2 days.
Jihad Abram says thank you. And Minawe Mahambe says great.
Here we go.
We are back on the road.
We're back on the road, guys.
Let's Tala Mats.
Time to
Portland High
Dala.
School in the house.
Time to Dala.
Brighton says we need to get cooking now. So there we go. Locked in.
We need to be cooking, not cooked.
Yeah. We're frying our eggs this morning.
Let's go. Right, watch this. Let's all do this. Can I do the first one for you? Remove the brackets here. X squared minus 2x times 2 minus 4x plus 4 minus 1 greater than or equal to 0. Please tell me you all got that. Beautiful. X squared minus 4x plus 4 minus 1 plus 3 greater than or equal to 0. Let's break that up. Greater than or equal to 0. X, 3, 1. Minus, minus. Plus 3, plus 1. Yebo, yes. Nice. Now, let's put our answer. Many of you go and say x equal 3, x equal 1. No, these are your critical values, CVs. It's E. So there we go. It's a positive parabola because x squared is positive. We put 1, we put 3. Greater than or equal to 0 means above. Where is this parabola above? Above there, and it's above there. So x is greater than, to the right, greater than or equal to 3, or to the left, x less than or equal to 1. Show of hands, how many of you got that one right? Well done. Well done. All right, now do the next one. I'll give you a minute to do it. Follow the same system I just showed you in the one before. Right, let's go. Now it's time for you to write your inequality. Remember, mathematics is about three things. S-A-N. Math is about three things. S-A-N. I'm going to write it out here for you. S-A-N. S for speed. Work fast. A for accuracy. Work accurate and make sure that your algebra is on point. And N for neatness. Have structure. Work fast. Make sure your algebra is on point. Work neat. Step by step. Right. Greater than or equal to means above. Where is this graph above your x-axis? It's above there and it's above there. Did you all do that? Beautiful. So put an x here and put an x there. So here x is between these 2 points. X less than or equal to 2, but greater than or equal to -1. Or to the right of 3. X greater than or equal to 3. There we go.
Question.
We all good?
Question.
Lovely.
How do we know whether it's concave up or concave down?
That we are getting to when we do calculus. That we will do when we are doing calculus.
Zafar said, sharp, thanks.
Right.
Zafar.
Lovely, Zafar.
Tara.
Onliners, when we are getting to calculus, we will do concavity, increasing, decreasing, concave up, concave down.
So Jade is on it today, Mr. Kota. She's blazing here. She's top of the comments, top of the tops.
Lovely, lovely, lovely. Now, here comes another question, guys. Here comes another question. Right, I want you guys to try this one. Now we're squaring both sides. So this one, 2 into x plus 10 minus 10 is equal to x minus 12. Solve for x. Meow, meow. Nothing happening. Meow, meow. Come, guys.
Just putting another cable in there, so just bear with us. So question, Mr. Kota, how many marks for this question here that we're dealing with? Samit,
4 marks.
how is it going with our wide screen there? How many marks for this question?
5 marks.
5 marks there, Tavina. We answered Tavina's question there. 5 marks for this question. Train Kitty, thank you. Let us know in the comments from which schools you are connecting to us from. Let us know how the session is going, besides some of the standby times that we are having. Speak to us in the meantime, Mr. Kota. What's the next we will be dealing with, and Give us an
We're
overview
going to be
of this
finishing
question.
up. We're going to be doing some one or two higher order questions, squaring both sides. And then we're going to go on to a simultaneous equation, couple of simultaneous equations, and nature of roots. Hey, guys, don't forget your nature of roots, eh? Delta.
On the 216 stream 1. I'm
Here we
on.
go. We're on.
Connected.
Yeah.
It's secured. Everything.
Must I disconnect and reconnect?
Yeah, just connect. Just plug this into this machine.
We're just adding a new cable in there so we can have a super fast connection, uplink. Just be on standby.
Can I press? Yeah.
We're giving Mr. Kota an extra boost. Technical team
Okay,
is
I'm
working
not connected
overtime
to the
today.
internet now. Should I connect?
Yeah.
To which one? This one. 216 stream 1 or stream 2? Stream 1 or stream 2?
I think it's 1.
Just wait. Connect on 1.
1. Stream 1. Yeah. Connected. Shows connected. 216 stream.
Okay, I'm on.
On.
Yeah, but now, okay, give me picture here. Give me whiteboard here, bro. Must I close it? Okay. All right.
Just be on standby. We're going to put Mr. Kota's whiteboard so we can commence the session.
Here we go. Am I live there? Get me up. I'm not even picking up my pen now. And I'm not even picking up my whole laptop has. Okay, here, wait. What's going on? I can't.
To share screen.
Wait, let me go out. Don't say. Right. What must I do? Why is my pen, man?
Need to share screen.
Yeah, but wait, I'm not getting my.
Duplicate the screens here on your thing. On your PC, please.
Okay, what's happening here? I'm not. Wait.
It's stuck.
the session. We are back for good. Thank you so much. Learners, can you kindly take seats? We will be resuming now. So we are the teachers. Teachers, if we can kindly call on you to settle the learners. We are about to start now. Teachers, if you can call some of the learners to be seated, we'll appreciate that. First break is at 10:30. Yeah. Kouter, it's up. Out here with
Internet
it was work here. Guy, can you come? You start. We've got that internet's working. And guys, it's also got 60 up and 60 down internet. So they wait. What is he? Whoa. Just. Swami? Swami? All right. Let's speak to Swami.
We need to simplify here and get rid of that third again. I'm erasing the top because of space. Right. Minus 2 times the square root will be 2x squared. Minus 2x minus 1x minus 3x plus 1 equals 3 minus 3x. Agreed? Right. Let's square both sides again. Yeah. Sorry? It's frozen. Hassan, sound? We back. Let's go. Now we square both sides again. Square that side and square that side again. Square both sides again. Right. Negative 2 squared is how much? 4. Square and square root will cancel. You're left with 2x squared minus 3x plus 1 is equal to. My right hand side, we're squaring a binomial again. We do the same thing that we did before. Square the first term, 9. Square the second term, plus 9x squared. Yes or no? Middle term, multiply the 2 and times it by 2. Minus 9x times 2, minus 18x. Now all we do, collect our like terms, make it a quadratic equation, and solve for x. So this would be 8x squared minus 12x plus 4, I'm multiplying this inside, is equal to 9x squared minus 18x plus 9. Agreed, guys? Collect our like terms. 9x squared minus 18x plus 9 minus 8x squared plus 12x minus 4 equals 0. 1x squared minus 6x plus 5. Yay! At this point here, ting, 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 we don't think we're right, we know we're right. Why do we know we're right? Because it's a perfect trinomial. It is a perfect trinomial. Now we factorize that. X, 3, 2, minus, x is equal to 3, or x is equal to 2. There we go. Yes. Oh, it's far. Oh, no, it's not. Okay. I was just testing whether you were paying attention. 5 and 1. 5 and 1. Jalamut pop. 5 and 1 minus. X equal 5, x equal 1. There we go. Well done, well done, well done. No, I left this on the, I brought all this, I changed all these signs. So plus x squared went on the other side as minus x squared. Minus 12x went on that side as plus 12x. Plus 4 went on that side as minus 4 to keep it positive. Answer is the same. You would have had it in terms of negative, you would have had to divide everything by negative again. But as long as you got your perfect trinomial and you got those two solutions. Right, let's end up this with a simultaneous equation. Those of you who have taken this one down, let's start with the next one already. The square root of 3 to the power x times, give me a second, I'll come there, times 9 to the power y is equal to 27, and x plus 4y squared is equal to 6. Solve for x and y. Okay. Let's go, guys. Let's go. We're going to wrap up with this and then we're going into inverse functions. Very, very, very important. We're going to do the inverse functions of all the different types. All right, question, answer. 3 to the power, we know this is the square root of x, so it's x over 2. Inside power divided by outside root times 3 squared to the power y is equal to 3 to the power 3. Yes or no? So 3 to the power x over 2 times 3 to the power 2y is equal to 3 to the power 3. We multiplying and bases are the same. What do I do to the powers? Add. So it's 3 to the power x over 2 plus 2y is equal to 3 to the power 3. Agreed? Well done. 3 and 3 cancels out. X over 2 plus 2y is equal to 3, equation number 1. All with me? If you wanted to, we can multiply everything here by 2 to get rid of that 2. We could. It would be nice. Let's multiply everything by 2. Times 2, times 2, times 2. So what would that give me? 2 and 2 will cancel. I'm left with x plus 2 times 2 is how much? 4y is equal to 6. So x will equal to 6 minus 4y. Now we sub it in. We sub it into equation number 2. Substitute. Can I continue on the left? So 6 minus 4y plus 4y squared minus 6 is equal to 0. This question is from the prelim of last year, 2024 Gauteng prelim paper. Continue. Don't wait for me because this is your prep session. By the end of this weekend, you must be fully prepped to write your prelim paper. I say we go till 5 o'clock today. You'll see, I promise you, when we get into calculus, you're going to say, sir, go on. Don't stop. I say we have a sleepover and we have pizzas and math tonight. (4y squared minus 4y). 6 minus 6 is 0. 4y into y minus 1 equals 0. 4y equals 0. Y minus 1 equals 0. Y is equal to 0. Or y is equal to 1. How many of you got that one right? Yay! Well done. Now, so x is equal to 6 minus 4y. There we go. Or x is equal to 6 minus 4y. X is equal to 6 minus 4 into 0. X is equal to 6. Or x is equal to 6 minus 4 into 1. X is equal to 6 minus 4 is 2. Beautiful. Well done. Okay. Okay. I'm now going to teach you guys the inverse functions, and then I'm going to then take from the prelim paper, and we're going to crack it together. And I promise you, you're going to get it right. But you need to pay attention. You need to focus on the different forms of inverse functions. Let's get started. Right, put the heading inverse functions. Now we all know what the general rule is for inverse. Inverse means opposite. What does the word inverse mean? And what do you all know from school? What is the inverse? Swap the x and the y, and then make y the subject. But now wait, I'm going to show you shortcuts and I'm going to show you hacks. Right, watch here. Watch here. Here's the first shortcut. Okay, so now it's shortcut time. Shortcut time. Right, let's go. Your hyperbola with a shift in asymptotes. So let's say h of x is equal to 3 over x minus 2 plus 1. Pay attention. I'm showing you hacks here. There are 3 big hacks. There are 3 big hacks. And I'll show you how easy, because it's going to save you time, and we need to save time in the exam. Am I right? That's how you can finish. Some people finish the paper in 2 hours and you think that they're geniuses. They're not. They just know the tricks of the trade. Watch here. h of minus 1. Put your pens down. You want your answer in one step, without swapping the x and y and making the y the formula. H equal to 3 over x. Keep the signs minus and plus. Just swap these two. Bring the 1 down. Bring the 2 up. Bada bing, bada boom. That's the inverse. That's the inverse. That's the inverse. You are, okay? You don't believe me. All right. Okay? Watch here. Watch here. Watch. So now you'd say you want to do it the long way in the exam, right? So you want to say x is equal to 3 over y minus 2 plus 1. Let's see if we get the same answer. Let's see if the way you do it and I do it, we get the same answer. Watch. So take the 1 on the other side. X minus 1 equals 3 over y minus 2. That's over 1. We want y on the top. Y minus 2 over 3 equals 1 over x minus 1. We multiply this side by 3. We multiply, so y minus 2 equals 3 over x minus 1. There we go. You're going to take the minus 2. You're going to take it on that side. Bada bing, bada boom. You and me, we get the same answer. There we go. I told you I'm not here to waste your time. I told you I'm not here to waste your time. You don't need to take this one down. Just do the shortcut. You keep it like this. You keep the sign. You only swap the P and the Q. Just swap these two. You'll get your answer. It's only 1 mark in the exam. It's only 1 mark. You get no marks for process. That long process will help you to fail. 1 mark. Give the inverse function. There's the inverse. So let's do one more. Come on. Let's say g of x is equal to minus 6 over x minus 5 plus 2. Come on. Just by looking at it. This is how you become smart. G of minus 1x will equal to minus 6 over x minus plus. What must I do? Swap the 2 and 5. Game over. Problem solved. Right. That's the first shortcut. For the hyperbola with a shift in asymptotes. The second shortcut. The second shortcut is if you had f of x, or let's say h of x. Now let's do the exponential and log. Exponential to log. So you know that h of x is equal to 2 to the x. Let's say, for example. Now I'm going to show you the long way, which I don't want you to do in the exam. Because it's only 1 mark. Right. So on this side, I'm saying don't do. So normally you would say now x equal 2 to the y. Yes or no? Then you would attach logs on both sides. Log x equal log 2 to the y. Then you'd bring the y in the front. You'd say y log 2 equals log x. Then divide by log 2. So y equals log x over log 2. Yes or no? So y equals, if it's log of a number to the same base, this would be log 2x. Yes or no? Now watch. You don't do. In your final answer, h of minus 1x is equal to log. If the base is 2, you make the base 2 and make the x. That's the shortcut. Finish. I'll show you. You want to do another one? G of x is equal to a half to the power x, which is a negative exponential. So it must be a negative log. The inverse, g of x, will equal to log of a half x in one step. Maybrew. Maybrew. And the last one, so now you got 1 shortcut, 2 shortcuts, and you're going to see we're going to be applying these shortcuts in the prelim paper, and we're going to get full marks for it. You're not losing any marks. How can I fly all the way from Joburg to come here to make you fail? Do I look like from Durban? No! Right, last shortcut. So this is exponential to log. Hyperbola would shift in asymptotes. Shh, pay attention. You're going to take home a wealth of information today. I'm going to show you shortcuts throughout. Every topic will have hacks. It's going to make you warm. Make your face in math. Right. The parabola, watch here, f of x is equal to 2x squared. Now, we don't want to swap the x and y. We don't want to do the long. We nar of math. We gat full of math. We want to do shortcuts. We want to short circuit the system. We want to bypass the system. So watch here. Let's get our answer in one step. F of minus 1x. Now remember, the word inverse means, so right, what's the opposite of square? What's the opposite of square? Thank you, but we put plus minus in front of it, yes or no? Shh, wait, don't write. Watch the shortcut. The opposite of square is square root. So whenever you see a square root, you know it's the inverse of a parabola. Are you listening? Mamela. What's the opposite of 2 over 1? The inverse of 2 over 1? 1 over 2. We took out the square. What's left over? Final answer. Are you liking it? You want to do another one? Yeah, of course. I'm going to show you a couple of them. I'm erasing the ones on the left. I'm erasing the ones on the left. Come, let's make up one. G of x is equal to minus 3x squared. Question, answer. Inverse. I want the inverse. Right, let's all do it together. Put your pens down. G of minus 1x equal. The opposite of square is what? What's the opposite of minus 3 over 1? Minus 1 over 3. X. For x less than or equal to 0. You have to put this restriction because you can't have a square root of a negative value. A negative times a negative will make it a? So you just leave it. You put for x less than or equal to 0. That's your final answer. That is your inverse. That is your inverse of your parabola. Parabola with a shift. You're only going to get this. This is the parabola that you're going to see. No shifts. No shifts. Right. I'm going to show you one more hack. No, two more hacks in functions and inverses. And then we're going to crack the functions component of this paper, and I promise you we're going to get full marks for it. So don't panic. I got you. Okay. You guys want to try one on your own quickly? Let's make one up. H of x is equal to minus 2x squared. Give me the inverse function of this. Quickly. Shouldn't take you more than 10 seconds. Write it. Plus, minus, call it out, I like. Square root of minus 1 over 2x. Finish. That's your inverse. Well done. Well done. Guys, there we all right. So far, so good. Lekker.
Show us signs of life.
Lekker like a cracker. Even for a flavor, meron. Some tomatoes for a party. I met him in Grassy Park as I was coming down the M5.
No,
on the
Mr.
corner there.
Coulter,
You were
record.
standing.
Red card,
Even
red
for a
card.
flavor, tomatis for a party, meneer.
We speak English, proper English here in Cape Town. Please.
Okay,
Discipline.
let's go. Right, here's another hack for you. Watch. Fun times. Shh. You know you got a let's say you got a standard hyperbola, right? You got a standard hyperbola, and that hyperbola, they give you a point P, and they tell you that is a point 2 and 4. And they told you to find the equation of H. Find the equation of H. And you know H of X is equal to A over X. It's a standard hyperbola. Yes or no? Shortcut. Here's shortcut for you. Check here. You have to watch. So put down your pens. Only for this, for hyperbola with the shift in asymptotes. Check it out. H of X is equal to, we're getting our answer in one step, over X. All you do, you multiply these two coordinates. Any pair of coordinate, you multiply. 2 times 4 is 8. Finish. Game over. You got the equation. That's it. You want to see why? You want to see the long way? All right, I show you. Well, I got to justify my stance, right? So let's go. Watch. So you're going to go y equals a over x. You're going to say 4 equals a over 2. Then you're going to multiply by 2, a equals 2 times 4. A equals 8. Y equals 8 over x. H of x equals 8 over x. Are you going to do all this for 1 mark? You're mad in your head. we can't use that. Are you just...
Hey, Mr. Kauta.
Okay,
It's a family-friendly show, man.
Astaghfirullah. Astaghs.
Sorry, apologies for that profanity. Clean your head, Mr. Kauta. Your head's in the gutter.
At least I got them laughing after this morning torture session. Let's not go there. All right, so there we go. Shh. That's your shortcut. I'll show you again. Let's do another one. I'll show you again. Let's do another one. Let's do another one. Check this one out, guys. I give you a hyperbola like that, graph G. I give you a point here, R. I tell you that's -3 and 5. Give me the equation of G. Come on. What I taught you here, apply it here. Just by looking at it, -15 over x. Finish. Done. Okay. Right. Now comes some, we're going deeper and deeper. Now that I showed you the shortcuts that we'll be using, let me show you what the inverses will look like. Very important that you know what the inverses look like, because the one that came out of the past paper here, they gave you the inverse of the graph. Watch. So let's talk quickly. Let's talk about the exponential. Quickly. Let's talk about the exponential. So let's talk about y, or h of x, y equal 2 to the x. So that means the inverse of it would be y equals log 2x. Then let's talk about y equal half to the x. And let's talk about its inverse, y equal log half x. Now we're talking math. Enough of the easy stuff now. Now we're getting into the meat of math. Right. Let's do a rough sketch of what that looks like. You need to know what its shape looks like. Positive exponential, we know the graph is going to go like that. And we know it's going to go through the point 0 and 1. Yes or no? You all know that. going to go down like that. And it's going to go the opposite. And if there was a point here, 2 and 4, then this here would be 1 and 0. And you'd have another point there. Because it's the inverse, we swap. So it would be 4 and 2. Yes or no? Good. When this is a fraction, then the graph is going to go down in the opposite direction. Oh, no. It's a log graph, right? It's an exponential graph, but it's a negative exponential going in that direction. That's also 0 and 1. And then the log graph, we all know, is now going to come down in the opposite direction. And that's going to also be 1 and 0. Please know these shapes. That's your exponential, that's your log. Now we're going to go into parabola and its inverse. Very important, because the parabola and its inverse is the one that came out in the prelim paper. The inverse of the parabola came out. We're going to finish functions, then we're going to go for break. We're going to go and have a lekker breakfast. How are we looking on time?
Okay, so guys, we're just having a look at our timing. That look, you have to have a refresher, stretch your legs. We also have to feed you, but also we have to make up time there, you know. So we'll find the middle path. So what we were thinking, Mr. Kota, besides your comfort break, I was thinking instead of 12:30 for the lunch break, if you are happy with that, it's a democratic society, we could have 12:45 until 1:15. It's for your benefit. It's for all of our benefit. So instead of 12:30, if you are happy, raise your hands and say aye.
Aye. Right. Good.
Okay, is that unanimous?
Lovely.
Okay, there we go. So Kota, you happy with that?
But what's the time now? How are we looking on time? 11:15. So
Yeah, so look, so let us just stretch.
Till
I was thinking, I'm thinking out aloud, if we
I said
had
we
to
go
forego our leg stretch, or
so
do
we
you
go
need
till
a
12:30.
12:45?
Yeah, they'll be okay, because this is work they need to know.
Okay,
We're
it's
working
for your benefit. I don't mind having a lunch break the whole
Yeah.
day, but I'm just trying to
We'll
make up.
sort it out.
So 12:45, if you guys are happy, we're gonna skip our
Yeah.
comfort break now. Say hi, then we can go for it.
Right, yeah. We good. Right,
Okay,
let's go.
there we go.
Right, Jazakallah. Thanks,
12:45.
Hasanain. Let's go. Now this graph, 2x squared, very important that you know how it's drawn. 2x squared looks like that. It's a positive parabola. Now its inverse is f of minus 1x is equal to plus or minus the square root of 1 over 2x. You see, if I didn't show you the shortcut and I just put it there, you'll say, yo, sir, how did you get that? Now we're on the same page. Now, if it's pointing to the positive y, the inverse is going to point to the positive x. That's f of minus 1. Are you all with me? This inverse is not a function. They'll ask you, is it a function? It's not a function. Why is it not a function? Because it's a one-to-many relation. For one x value, there are many y values. So the inverse is not a function because it's a one-to-many relation. What do you think the next question is going to be? How would you restrict the domain so that the original or the inverse becomes a function? Right. So how would you restrict the domain? How would you restrict the domain for it to become a function? You know, for x greater than or equal to 0, That would be, watch here, put your pens down. If I restricted the domain for x greater than or equal to 0, that means I can't have the negative part of the parabola. That means I won't have the negative part of the inverse. So therefore, the top part is a function now. Or, if I say for x less than or equal to 0, now what I'll be doing is drawing the negative part of the original. Watch here. For x less than or equal to 0, let's say for x less than or equal to 0, now I'll draw the negative part of the positive parabola, and then the negative part of the inverse would be a function. So this would be f, that would be f of minus 1, because we've restricted the domain. So these are your two answers, for x greater than or equal to 0, or for x less than or equal to 0. Take that down. That's how you'd restrict the domain for f of minus 1 to become a function. Okay. So let's have some fun. Take a deep breath. We're going straight into the prelim question. Just assume you were writing, you were in your exam. The next question is going to appear. It's the first question, the opening question of your prelim paper. They give you an inverse of a parabola. So watch here. I'm erasing. Take the diagram down quickly. Here we go. Here's the question. That's 0. That's your y-axis. That's your x-axis. This is your prelim question. And they give you a graph coming down like this. And they give you a point here, P, minus 6, minus 8. They tell you the graph f of x is equal to ax squared for x less than or equal to 0, and this point lies on the graph. Now, before we even start with the questions, let's all look at it and smile. You know why? Because we know that because it's going down, they're already telling you ax squared. So you know it's a parabola with a restricted domain. Basically, it's half a parabola. The original parabola of that would have went like that. But they restricted the domain. They restricted the domain. So your graph looks like that. So now we've identified what type of a graph is it. What type of a graph is it, guys? A negative parabola with a restricted domain. Are we on the same page? Excellent. Now let's start answering the questions. Right. Question number 1. They want the value of A, obviously. The question number 2, the equation of f of minus 1, the inverse. In the form y equals the range of f of minus 1. Sketch f of minus 1. If f is reflected about the line y equal x, and thereafter reflected about the x-axis and about, the x-axis. Give the new equation. There we go. 5 questions here, 9 marks. 5 questions, 9 marks. Let's get full marks here. So take down your questions. The value of A, equation of f of minus 1, the range of f of minus 1, sketch the graph, and if f is reflected about the line y equal x and about the x-axis, give the new equation. Okay, let's answer question number 1. Let's all do it together, as if you are writing your exam. You know y equals ax squared. That's your original. They want the value of A. You got a point on the graph, x, y. So let's substitute. Minus A equals A into minus 6 squared. Yes or no? Let's all solve for A. Minus 8 is equal to 6 squared, 36A. A equals minus 8 over 36. A equals minus, right, 4 goes into there 2 times, 4 goes into there 9 times, minus 2 over 9. Very good, I heard that coming from that side. Well done. Are we all okay, guys? Grade 12s, we good? Lovely. How many marks was that? 2 marks. So now what you do, you go back to your equation and change it. So now say f of x is equal to ax squared minus 2 over 9x squared for x less than or equal to 0. It's a restricted domain. If it's not the technical, we have drilling. If it's not drilling, we're going to have a tornado. What next? All right. Where's my bra, Sanain? Right, let's do the next one. Answer the question number 2. Please just tell him to stop drilling. I don't know where they're drilling. Right, f of minus 1. So if we know f of x is equal to this, f of my... What are we expecting? A tornado next?
Yes, please, just indulge us.
Right.
They're drilling and they're putting an alternative satellite thing, a Starlink, up to the moon to ensure a reliable internet connection.
We got Elon Musk in our house here, my bro. Here,
So it'll just be a few seconds of little bit noise, but we're all good to go. You're doing well, Mr. Kauta.
We're moving Starlink now.
Starlink. No, we can't go GPRS and 3G, not helping us.
Now watch here. Very important, the next question. Guys, lock in. Lock in. Watch. Shh. Now pay attention. Here comes the trick. Because when there was no restriction, listen to me and listen carefully. When there was no restriction, we put plus minus in front of the... Remember when it was just 2x squared, we said plus minus the square root of a half x. Yes or no? But there's a restriction, my brother. Ladies. There's a restriction. So it's minus the square root. That's the restriction. Minus the square root of minus 9 over 2x. That's your answer. In the form y equals, so y equals minus the square root of minus 9 over 2x. So the outside tells you your restriction. Your inside sign tells you the original, whether the original was positive or negative. Very important. Mundo importante.
Mucho.
Mucho. Mundo.
Mucho, man.
Mucho. Okay, mucho.
You're butchering my Spanish language.
Mucho. But isn't mundo Italiano?
No. Yeah, Italiano, but we're talking
Mundo.
Spanish here, man. We're in a Spanish fella.
Are we good, guys? Did you get that? Did you take that down? Why did I put a negative outside? Because of the restriction. If it was x greater than or equal to 0, I'll put a positive outside. Right. Now it's important. They're asking you for the range of f of -1. So it's important to know what it's going to look like. The original is a negative parabola. So a negative parabola would look like that. A complete negative inverse would look like that. But for x less than or equal to 0, it would only be the bottom part. So this is what f of -1 looks like. If that is f, this is the negative part of the so the negative part of the negative parabola. Now what is the range? It's very important. The next one is to sketch. There's it. We've already done number 4. So what's the range of this? I'm answering question number 3 now. Y, the range, your y values, less than or equal to 0. Yay! High five! So just to show you here, let's draw it again here on the top for you. There we go. I'm doing the same thing again. The negative part and the range here will be y less than or equal to 0. The negative part of the negative parabola. Sketch f of -1. Done. But we need a point on another graph. We had a point on the original graph, so this will be P dash. And the 2 must swap over. Will become -8, -6. You have to show that other point. Because on the original graph, they gave you a point. So on the inverse, you just swap it over x and y. Now, if f is reflected about the line y equal x, so that was the inverse. Now they're telling you, flip the inverse about the x-axis. So watch. So they're telling you, flip the inverse. About the line y equal x is the inverse. So basically, what does this question mean? It means flip the inverse. Okay, let's do this. Your original graph is f of x is equal to -2 over 9x squared. About the line y equal x is the inverse. So now that would become f of -1x is equal to, I'm just erasing here. What did we say? Minus the square root of -9 over 2x, right? That's your first reflection. And about the x-axis. Reflection about the x-axis, what happens? The y sign changes. The y sign changes. About the x-axis, the y. So minus y is equal to minus the square root of -9 over 2x. In your final answer, can y ever be negative? No. So divide by negative, divide by negative. Here's your final answer coming up. y equals the square root of minus 9 over 2x. And that's your final answer. We just scored ourselves the first 9 marks in the prelim exam 2024. Gauteng. The next one is an exponential. The next one is an exponential, and in my mind, I'm already thinking that they're going to ask me about the inverse of that exponential, which is a log, and we're going to be utilizing the shortcuts that I showed you. How's our onliners doing?
Blazing.
Are they blazing? Are they feeling the math?
They forgave you.
Forgive me.
Oh, sorry, the tech team.
I was born ready, bruh.
Safar Kala said, yeah, I'm quite sure. So look, just an update for our onliners. We will be having our break at 12:45. We're making up time. We're doing well. Thank you so much for your patience. Jade says she's alive and well.
Thank you, guys. Onliners. Stay with us. Stay with us. We're here to get you your distinction, brah.
Qasim Abram says, let him cook. We're back.
Now, guess what they did? Must I tell you what they did in the prelim exam? They asked you about, before they even started with this, they started with, do you guys remember in grade 10 you did a topic called rotation and reflection? I know you don't remember it. I swear they asked you a rotation question. If a point is rotated, right, I bet you forgot that law. I bet you want me to give you the law, right? So let's give you the laws of rotation. Right. Here's your, before we even start with this, put down your rotation laws. Now, let's take a point P, 2, and 3, for example. And they want you to rotate it 90 degrees anti-clockwise. Or 90 degrees clockwise. 180 degrees anti-clockwise. Or 180 degrees clockwise. What are the rules? So learn these rules of rotation. You need to have it in your toolbox of knowledge. Here goes. 90, that's why I put it, learn it in this order. 90 anti, 90 clock. 180 anti, 180 clock. Because P dash, the two swap over. 3, 2. But the X sign changes. Here, clockwise, the two swap over. The Y sign changes. That's why I put it anti-clockwise and clock, because X and Y. So it's easier for you to remember. Swap and the X changes, swap, the Y sign changes. 180 anti, 180 clock. They stay in the same position from the original. But both signs change. There's a reason I'm giving you these rules, because the opening question in the prelim paper grade 12 is a rotation question. And if you didn't know these rules, you forgot these rules, you didn't learn these rules, you're going to lose your first 2 marks. This next set of questions, 2, 4, 2, 4, 6, 8, 10, 16 marks for this block of questions, which is question 2, functions, prelim, Gauteng 2024. You took it down? Learn. Memorize this for your exams. Okay, your rules of reflection, let's quickly go through it. If something is reflected about the x-axis, y sign changes. About the y-axis, x sign changes. About the line y equal x, the inverse. Yes or no? That's reflection. Rotation, 90 anti. They swap, the x sign changes. 90 clock, they swap, the y sign changes. 180 anti or 180 clock, they stay the same, both signs change. That's what you got to know before you walk into the exam. Now let's go. So I'm giving you the first question. I'm sure you're all now you're going to fly through the questions. The first question is, the point P, 2 and square root of 3 lies on a Cartesian plane. Find the coordinates of the image of P if P is rotated. If P is rotated 90 degrees anti-clockwise. Come on. Now we can all smile. We're all going to get it right. Your opening question, your first 2 marks. So don't think rotation will not be tested in grade 12. So far so good, grade 12s? I hope you're learning. And this is going to be a fantastic refresher. Tomorrow is compound and double angles, circle and guys, you don't want to miss it. We got hacks there as well. I got templates for Africa. Finance today, you're going to love it. How many of you did finance in school? How many of you have done finance? Future value, present value, annuities. Oh, you're going to love today's. Balance outstanding on a loan, trade-in of an asset, immediate payment, deferred payment, final payment. I'll show you how to tweak the formulas. That's what we're here for. This is what we came for. Right. So what's your answer to the first one? P dash 90 anti. The 2 swap over, the x sign changes. Did you all get that one right? Yay! Your first 2 marks. Woohoo! Right, now we get to the graph. Now we're on to the graph. Why are the graph h of x is equal to h of x is equal to a to the power x, so we know it's exponential, and it lies on the graph. Right, question number 1. Why are the coordinates of why are the coordinates of q? Why is q's coordinates 0 and 1? Substantiate means explain. Why? Why? Yes, lovely. I like that answer. It's an exponential. Whenever x is 0, y is 1. So you can say it's an exponential graph. It's an exponential graph. And any base, any value of a or any base to the power 0 to the power when x equals 0
its function value will always be 1. Its function value will always be 1. Basically the rule, any base to power 0 equal 1. Can answer it like that. They just want to know in English, do you know why for any standard exponential graph, why is that intercept 0 and 1? What do you think the next question is going to be? If they told you, you are always looking for A. Whenever a graph is given and an equation, whether it's parabola, whether it's straight line, whether it's hyperbola, whether it is, no matter what, we're always looking for A. So what do you think the next question is? Find the value of A. Right, so go ahead. Find the value of A. Find the value of A. Khalid, how are we doing there, bro? How's our onliners doing there? Talk to us. Where are they? Give us some feedback there. Right. Question number 2, the value of A. After this, we're doing a hyperbola with a shift in asymptotes and all its different forms. You have to know it. Right. This is question number 2, the value of A. So y equals A to the x. We got a point minus 1.5 x and y. Normal algebra, that's y. So a half equals A to the minus 1. A half equals 1 over A. Flip this side, flip that side, A equals 2. Or cross multiply if you want. You can even cross multiply. A is equal to 2. Go back to your equation, h of x is equal to 2 to the x. In most cases, for exponential, it will either be 2, 3, 2 or 3. They'll use the number base 2 or base 3, or half or a third. Most commonly asked ones. Are we all locked in? We're still there, focused. Don't DC now. Don't disconnect. Stay online. How's the downloading speed? 5G. I hope so. Shh. You know you're writing on us. Okay, next question. The equation of the inverse. Come on, come on. They want the equation of the inverse, h of minus 1. The equation of the inverse. Question number 3. The equation of the h of minus 1. Come on. What's the inverse of an exponential? A log. I showed you the shortcut, isn't? So here's your answer coming up. H of minus 1x is equal to log x to base 2. Finish. Nothing more. Shortcut. Bypass. Draw h of minus 1. Right, let's draw h of... Question number 4, draw, sketch h of minus 1. And label fully. This is a positive exponential, so you must have a positive log. And I showed you what it looks like. Positive exponential, positive log. If that point there is 0 and 1, what is this point? 1 and 0. This is the point A dash half. No, we need to go half and minus 1. So half on my x, sorry. So it's not there on the top.
It's not there on the top. The point is here. There's the point, a dash. Let's flip the 2 over, a half and minus 1. And this is h of minus 1. Finish. Full marks. Okay. Where is h of minus 1x less than 0? Where is h of minus 1x less than or equal to 0? What question number is this? 5? No? 6? 5? Right. For which values of x? Thank you. Your y-axis is your asymptote for your h of minus 1 graph. The graph will never touch your y-axis. So you can't say is equal. This graph will never touch. That's why we don't put a equal to sign there. You could write it like that, or if you wanted to write it in interval notation, 0 to 1. There's an equal to sign, so we put a square bracket. There's no equal to sign here, so we put a round bracket. So you could write it in interval notation, or you could write it in inequality form. Both of them are correct. Are we winning grade 12s? Show of hands, are we winning grade 12s? Good. Right, the next one. If g of x is equal to 100 times 3 to the x, find the value of x. Okay, so let's do this one. This is your last higher order question that they asked you on this. So we got h of x. H of x was equal to 2 to the x. H of minus 1x was equal to log 2x. Now they tell you do this one. If g of x is equal to 100 times 3 to the x, find the values of x. For which h of x is equal to g of x. Try this one on your own.
If anyone has an iPhone charger, please come to my rescue. My phone is on the blink. There we go. Thank you. As you are, Mr. Kota.
Thank you. So h of x, let's do this. For h of x to equal to g of x, what is h of x? 2 to the power x. G of x is 100 times 3 to the x. Basically, what are they asking you to do? Solve for x, am I right? This is your last question. This is the last question of this. Then we're going to go into the hyperbola with the shift in asymptotes. And then I'm going to show you some crazy moves. Right. How do we solve for x here, guys? In algebra, 2 to the x is equal to 100 times 3 to the x. I'll give you a minute I'll give you a minute to try and work it out. Let's see how many of you are sharp. Grade 11 is going to be here next weekend. Oh, then we're going to move the Starlink that side.
Got a new policy in our government, in our dispensation. Wherever we're going with our maths from now onwards, we're taking the Starlink with us. We can't.
Moving Elon Musk now.
No, even better, faster.
Tesla.
We can't disappoint our cohort of learners.
Whew.
Okay.
First say, I can't disappoint Mr. Kota.
Yes, I can't disappoint Mr. Kota.
Okay, here we go. The first thing we want to do here is divide by 3 to the x. Yes or no? Because you want the x's on the same side. Unlike in real life, never ever put your x's on one side. You're asking for war. 2 over 3 to the power x. See what maths teaches you, to put your x's on one side. Recipe for disaster, bruh. Imagine you walk into a room and all your exes are in one room, waiting for you. Your people are putting their heads under the table here. They're waiting for you. All your exes together. Because you played them. You played the maths game. Some people are laughing because they're guilty. Right. What do we do? How do we solve for x? Attach a log, attach a log. So log 2 over 3 to the power x is equal to log of 100. Yes or no? And what's the first rule of logs? You bring the power in front. So if you don't know how to do logs, this is the way it's done. Attach a log on the left. What you do to the left, you do to the right. The next step, bring the power. Logs is the only system that allows the power to become the base. So now, x log 2 over 3 is equal to log 100. Now we isolate x like a normal equation. Divide by log 2 over 3. What I do to the left, I do to the right. Boom, boom. We're going to be using this in finance as well when we're looking for n. We're going to be using it in sequences and series when we're looking for n in a geometric. So x is equal to, let's go to our calculators, log of 100 divided by, where's my calculator? Log 100 divided by log 2 over 3. Log of 100 over log of 2 over 3. Negative 11,36. Let's go. Let's check it again. Log of 100 divided by log 2 over 3 minus 11,36. Okay. Something else I want to show you. Something else I want to show you. How do you solve a log equation? Watch here. Very important concept. So here, I'm going to put here concept. Concept. How to solve a log equation. Watch here. So if I told you log x to base 2 is equal to 4, for example, how do you solve for x? Right. For those of you who don't know, let me show you. I call it the smiley face method. The smiley face method, or what I call the winky eye. So we wink, wink. I'll show you. the winky eye method. It's my own method, my own way of making you understand. Not my method, it's just my way of explaining it to you to make it sound nice. So let's draw the smiley face. We start from the base, but you must have it in this form. Log of a number to a base is equal to a number. Watch here. Here's the smiley face. There's the smile. So 2 to the power 4. And now we wink across the emoji. So we go across. So 2, we start from the base. 2 to the power 4. Smiley face, winky eye is equal to x. 2 to the power 4 is equal to x without the log. So x is equal to, what is 2 to the power 4? 16. Right? So whenever you need to solve a log equation, we'll use this method, the smiley face or the winky eye method. So even if they told you, let's do another example. Right. Log 8 to base x is equal to 3, solve for x. Question, answer. Winky eye. Standard form. That's standard form. Standard form is log of a number to its own base must equal to a number. That's called standard form. Standard log form, log equation form. So you want to have a single log equal to a number. Now we apply smiley face or winky eye. So let's go smiley face without the log. X, there's the smiley face, x to the power 3, let's wink, is equal to 8. You see how easy is it? Let's now solve for x. Cube root on this side, cube root on that side. X is equal to 2. Are we all okay, grade 12s? They want a break? Are you guys tired? Are you moeg now? Let's check. Okay, let's go to vote. Let's vote. How many of you are hungry? No, this is Cape Town, bruh. Everyone's hungry in Cape Town anytime. I shouldn't have asked that question. I say, let's just do the hyperbola with shifting asymptotes, then we go for break. Or you want to go for break now? How many of you say break now? Yo. Okay, how many of you say last one before break? Are you guys lost? Sorry, you lost. Okay, listen. Last one. No, last one. Last one. Last one. Last one. Last one. Watch this. You guys thought you were vase, ne? All right. Check this out. H of x is equal to x minus 2 over x plus 6 is a hyperbola with a shift in asymptotes. Question number 1. rewrite in the form y equals a over x minus p plus q. Number 2, I want the equations of the asymptotes. Number 3, sketch the graph. And then I want the equation of the axis of symmetry for m less than 0. This is the last one we're doing in functions. We will then go for break. We come back and we're cracking calculus. And there's big stuff in calculus. Big stuff. Right, let's see who's sharp and who's smart. Obviously, how many of you have seen this question before in this style? Ooh, only 5 from 600. Julle gaan dryp. Julle gaan... All right. Okay. I know many of you haven't seen it before. Now imagine in a prelim exam, you thought you knew hyperbola would shift in asymptotes. You find there, skitty, dancing. You open up the paper, you see the thing, you say, there's it. I might as well go work for Checkers or Pick and Pay. Some of you at this point, after looking at this question, you're already thinking maybe you should have done diet maths. You know, maths light. Maths 0. All right. Shh. Watch here. We are rewriting it. So watch here. H of x is equal to. This is how we do it. You take the denominator, we copy and paste it on the top. Step number 1. Shh. Don't ask why. I'm showing you why. Just shut up and listen. Don't ask. Just keep quiet. Right, now pay attention. We copy and paste. Now, we have to rewrite. So my numerator must be minus 2. I got a 6 here. So watch here. Minus 2 plus a certain number. Now, let's go back. 6 plus a certain number must equal to minus 2. We're rewriting it, so we're not allowed to change it. So that means I must still get minus 2 on the top. But what I did is I took my denominator, I copied and pasted it on the top. So 6, watch here, just pay attention here. 6 plus a certain number must equal to minus 2. So the certain number will be minus 2 minus... Oh, what's my... Yeah. Ay. Raza. I know. Hey, all right, okay. Let's go see what's going on there. It's like the ilachi in my biryani, brah. My karamong in my acne. My speed trap, I'm moving at 200 kilometers per hour, Dick. Runs across the khata. All right, you know what we do? While they sort this thing out, let's go for break and then we come back and finish. Wait. I'm giving you a break. It's 10 past 12. I'll see you guys back in here at 10 to 1. 12:50. Going for break. Go for break. I'll see you guys back here at 10 to 1.
Are we taking the break?
we're not gonna entertain 1. So there is provision for Dhuhr Salah. There is provision for Dhuhr Salah. On my side as
you. It's fine, yeah. Right. Hope you guys all ate nicely and you are fresh. Right, thank you guys.
Summit, we don't hear any audio. Okay, let's see. Can we hear?
I was just waiting for Hasanain to give me the green light.
Let us know if you can hear us.
Onliners, can you guys hear us and see us clearly? All good?
Okay. Online code, can you hear us? Yes, yes.
Yes.
Go
yes,
for it,
yes,
Mr.
yes.
Coach.
Here we
Take
go,
us
here we
away.
go, here we
Back on the
go.
road.
Right. Okay, let's go back to this. Let's start this one again. Let's start this one again. So in our answer, h of x is equal to, what did I say? What's the first thing you do? You take the denominator and you copy and paste it. Yes or no? Right. Now pay attention, guys. Thank you. Shh. Now we need to get a value here. So we say 6 plus a certain number must equal to -2. Yes or no? So the certain number is -2 minus 6. The certain number is -8. So we put -8. Because +6 minus 8 will give me -2. Agreed? Pay attention. Pay attention. We're not yet done. Now we split it up. We split that up and we split that up. So we're going to have x plus 6 over x plus 6 minus 8 over x plus 6. Here's our final answer coming up. Here's our final answer coming up. That over that is 1. We're left with -8 over x plus 6 plus 1. A over x minus p plus q. Take this one down, guys. We split it up. We split it up. I'll give you another one. G of x is equal to x plus 4 over x minus 1. Let's see if you can get that. Use the same system and get that in the form a over x minus p plus q. Just don't mess anything up now because we are live. Don't touch nothing. We have to plug that thing, put it in my... Right. I'm moving this. I'm moving up here to the left. Let's do this one. G of x is equal to x plus 4 over x minus 1. G of x is equal to, what did I say? Copy and paste. X minus 1, x minus 1. Now minus 1 plus a certain number must equal to 4. So the certain number will be 4 plus 1. The certain number will equal to how much? 5. I'm going to put a tick there. Did you all get that? Good. Now what did I say? What do? We split it up. So we're going to have x minus 1 over x minus 1 plus 5 over x minus 1. You all agree with that? Any number divided by itself is how much? What's my final answer? 5 over x minus 1 plus 1. Done. A over x minus p plus q. Make sense, guys? Good. Now, let's go back to that first one that we did, h of x. This was just an example I gave you. Let's go back to that one. H of x was equal to, just call it out for me. What did we have? What was it? Minus 8 over x plus 6 plus 1. Okay. Let's answer question number 2. So we've answered question number 1. We got it in that form. The equations of your asymptotes. Now you guys know the word, don't get confused between the word asymptote and axis of symmetry. You know the abbreviation for asymptote is S. Now you know in life you can't go around touching anybody's. So you know asymptote is a line which your graph never touches. So whenever you see asymptote, don't touch. Haram. Jahannam. Hell. So the equation of your asymptote, x is equal to minus 6. We change the sign. Y is equal to 1. That's your p value, that's your q value. Are you all with me? That's the equation of your asymptotes. How do we sketch the graph? Now we need the intercepts with the axis. So we're going to say let x equal to 0. So y equals minus 8 over 0 plus 6 plus 1. Y equals minus 8 over 6 plus 1. Y. This thing going mad. What's happening here? Y is equal to minus 8 over 6 plus 1. Minus 8 over 6 plus 1. I get minus a third. So when x is 0, y is minus a third. X is equal to minus 6, y is equal to 1. X is equal to minus 6, y is equal to 1. Right. Now we're going to say let y equal to 0. So minus 8 over x plus 6 plus 1 equals 0. You all following? Solve for x. Right. So minus 8 over x plus 6 is equal to minus 1 over 1. Cross multiply. Minus 8 equals minus 1 into x plus 6. Minus 8 equals minus x minus 6. Minus 8 plus 6 equals minus x. Minus 2 equals minus x. X is equal to 2. So x is equal to 2 and 0, 0 and minus a third. There we go. Sketch the graph, draw a rough sketch of the graph, guys. Then we have to do the equation of the axis of symmetry with a negative gradient, am I right? Right, let's sketch the graph quickly, guys. Here we go. Here we go. X is equal to minus 6. 0. -1, -2, -3, -4, -5, -6. There we go. Put a dotted line through it. That's your asymptote. Your other one, y is equal to 1. There we go. These are our asymptotes. 2 and 0. 1, 2. And then 0 and minus a third. 0 and minus a third. There we go. It's a negative graph, and you know a negative because it's -8. So it will appear in your second quadrant and your fourth quadrant. And there's your graph fully sketched. There we go. Label your asymptotes, label your intercepts with your axis. The last question, the equation of the axis of symmetry. For m less than 0, y equals minus x plus c with a negative gradient. What points do I use for x and y? The point where the two asymptotes meet. Because with a negative gradient, that's your graph, that's your line. So now, we're going to use the point x being -6, y being 1. 1 equals minus into -6 plus c. 1 equals 6 plus c. 1 minus 6 equals c. C equals -5. Here's your final answer coming up. Y equals minus x minus 5. That's the equation of your axis of symmetry with a negative gradient. Agreed? Beautiful. Let's wrap up this with another question from a past paper with regard to the hyperbola with a shift in asymptotes. Very popular style of them asking you a question. Then we're wrapping up with functions. Then we're moving into our favorite topic, calculus. Yay!
Party pack a day, calculus. How are you doing, Mr. Kota? Well done.
All good, all good, all good. We are on fire here. We are cooking here. Right. For those of you, I know some of you are still taking down that one. Those of you who have taken that one down, you can start y equals x plus 5 and y equals minus x minus 8 are the two axes of symmetry of h of x equal a over x minus p plus q. Now we're doing the reverse. Now they give you the two axes of symmetry. Find the equations of the asymptotes. Question, answer. We're at the end of the functions here, guys. In fact, there's one more concept I want to teach you, which I explained to that one learner during break. When they give you an exponential graph and they ask you where is h dash x, the derivative of x, less than 0, on an exponential graph. I just want to show you that concept so that when you walk out of here, you know you've learned something. Because I know 99% of you sitting here are going to get that question wrong in the exam. If I didn't explain it to you, I didn't show you what to do, and if you saw it in the exam. All right, this is very easy. Shh. Guys. Right. These are our two equations of the axis of symmetry. So initially, when we found the axis of symmetry, we had to put in the point where the two asymptotes meet. Now they're asking you. So all you have to do, simultaneous equations. Equation 1, equation 2. All you have to do, x plus 5 is equal to minus x minus 8. You equate that to that. Solve for x and solve for y. Finish. Those are the two equations of your axis of symmetry. So x plus x, 2x, minus 8 minus 5, 2x is equal to minus 13, x is equal to minus 13 over 2. That's your p-value. And then y equals x plus 5, y equals minus 13 over 2 plus 5, y equals minus 6.5 plus 5 minus a half. And there we go. These are all they basically telling you is to solve for x and y. That's it. Learn this. Another tool for your toolbox. So basically, what will your equation look like? It would be a over x plus 13 over 2 minus a half. All okay? And then minus ratio. Okay. Now what next concept? I know this is now your introduction into calculus, right? This is your intro because there's a calculus question that's asked now in functions. Check the next question out. Yes. Question? What happened? Are you serious? Isn't this minus? 13 over 2 is 6.5. Oh, plus 5, 1.5. 1.5, so it's 3 over 2. Am I right?
See the sharp
Yeah,
here.
the sharp
How to
parrot.
do sharper image?
Negative minus there. Thank you. Lovely. All right. Thank you. Focus. Focus. We are focusing. All right. Check the next one out. And I know you guys have seen this before. Let's say, for example, they gave you a graph and they gave you a situation like that. That's an exponential graph. And this was 8. And they told you 8 of x was equal to 3 to the power x. For which value or values of x is h dash x greater than 0. I'd love you guys to try this one as well, because I know what many of you are going to be doing with this. You're going to be looking for the derivative, isn't it? H dash x is the derivative. Interesting question. Interesting question. And it's only worth 2 marks. Now, watch here. Okay, I know many of you are battling. I know you're sweating. What does the word derivative mean? What does the word derivative mean? It means the general gradient, wait, of any tangent at any point, of any tangent at any point on a graph, on any graph. That's what the word derivative means. The word derivative means gradient. So you know what to do? Right. All we have to do here, we don't find the derivative of this. You just wrote, look here, if I drew a tangent that way, it's got a positive gradient. If I drew a tangent that way, it's got a positive gradient. If I drew a tangent that way, it's got a positive gradient. So no matter where, which tangent I draw, it will always be greater than 0. It will always have a positive gradient. That means for any x value. So your answer to a question like this is you say x is an element of real numbers. For any x value, the tangent to this graph will always have a positive gradient. If they had to ask you, where is it less than 0? This graph only has got positive or tangents with positive gradient. Then the answer for that would be for no values of x. Because that graph never have a negative gradient. But that wasn't what was causing it. Oh, okay. Right, let's go. Another example of this is if I had a graph, any graph, right, for which value or values of x is f dash x less than 0. Let's say this was -1 and let's say this was 4. For which value or values of x is f dash x less than 0. So all we do, using the same thing that I showed you, pay attention, girls. We draw a tangent here, positive gradient. We draw a tangent there, negative gradient. We draw a tangent here, positive gradient. So for less than 0 is negative. So that's a positive gradient, negative gradient, positive gradient. So where is f dash x less than 0? It's got a negative gradient. Answer to this question is for x less than 4 but greater than -1, or you can say from -1 up to 4. That's where the tangent of the graph, has got a negative gradient.
So I'm just illustrating. You can draw tangents to a graph in order to find out where is the graph positive or negative. It's a good tool to use. Very, very good tool to use. And where a graph is negative, what is it called? Decreasing. When it is positive, what is it called? Okay. Let's now get into calculus. Right. What is your checklist for calculus? Let's write your checklist. Number 1, first principles. Number 2, derivative. Number 3, differentiation. Number 4, equations of tangent. Number 5, the cubic graph. Number 6, optimization. What did we say? How many marks, guys, in the exam? 40. A third of your paper is calculus. Okay. Let's start with one. If f of x is equal to 4 minus x squared, find f dash x by first principle. Question, answer. Now, obviously, guys, you had to have come today with some knowledge. You couldn't have come here blank and being taught, okay, a lot of things you're going to learn for the first time. But you got to, I mean, these words have got to be resonate with you. These words got to be familiar with you. Don't come to me afterwards, sir. Sir, please explain to me what did you mean by the word first principles. Don't write the exam. If you're coming right at this stage and you ask me what is first principle, you shouldn't be doing math. Right. Right. The first thing we do, step number 1, x plus 8. So f of x plus 8. Before we go into the formula, guys. So that's 4 minus, for every x, what must I put? X plus 8. You all with me? Let's remove the brackets. 4 minus into x squared plus 2xh plus h squared. That's 4 minus x squared minus 2xh minus h squared. Now, this is step number 1. Step number 2, f dash x, the general gradient, is given by limit h approaches 0, f of x plus h minus f of x all over h. So that is the limit as h approaches 0. 4 minus x squared minus 2xh minus h squared minus f of x minus 4 plus x squared. We change both these signs because of the negative. All over h. I'm moving over to the side limit as h approaches 0 minus x squared plus x squared plus 4 minus 4. Now we take out h on the top. So we left with minus 2x minus h all over 8. H and h cancels out. Now you say, but h tends to 0. Therefore, f dash x is equal. If that is 0, what am I left with? Minus 2x. Agreed? From a past paper. From a past paper. Minus 3 over n. Let's see if you can do one by first principles. How many of you have seen that one? Minus 3 over x, or 2 over x, or 1 over x by first principle. By first principles. So this was the first one. This was example number 2. Exam model number 2. Something to drink. Yeah. It's right here. Somewhere here. Come, guys, don't wait for me. You can start with the next one already. Again, I'm just asking you, your great show of hands. How many of you have seen this one on the board? Few of you have. Many of you haven't. You better learn it. You better learn it. Very important. Let's do it together, guys. F of x plus h will be minus 3 over, for every x, what must I put? X plus h. So f dash x is equal to, thank you, the limit as h tends to 0, f of x plus h minus f of x all over h. So it's the limit as h tends to 0, f of x plus h, there we go, minus 3 over x plus h, minus f of x, minus will give me a plus 3 over x, divided by h over 1. I moved it to the side because we don't want a fraction over a fraction. Are you guys following? Right. Let's go. I'm just moving over to the side. So this is equal to the limit as h tends to 0 times 1 over h. My LCD is x into x plus h. Lower LCD, because I'm adding two fractions. Lowest common denominator. So x plus h will cancel. I'm left with x. X times minus 3 is minus 3x plus x plus h. No, x and x will cancel. You're left with x plus h times 3 is 3x plus h. Now collect your like terms, remove your brackets. Normal algebra minus 3x plus 3x, plus 3x plus 3h over x squared plus xh times 1 over h. Minus 3x plus 3x is 0. H and here will cancel. Now we say, but h tends to 0. Therefore, f dash x, where's the final answer coming up? 0 times x is 0. What am I left with? 3 over x squared. That's your final answer. 6 marks for that. Learn. Let's go into differentiation. Derivatives and differentiation. Let's give you a couple of exam ones. Right, differentiate. That means find the derivative. Differentiate. Question number 1. Xy minus y is equal to I'm making up one. X squared. X minus 1, x plus 5. Right, there's the first one. There's the first one. Example number 2, d in this form. 5 over 3 square root x minus the cube root of x plus 2 over x squared. Right, let's do these two first. Now, obviously, in the first one, if it's y, they'll probably want dy over dx. Right, so watch what we do in our answer. The first thing we do on the left, we only want y on the left-hand side, so we got to factorize. So we take y into x minus 1. Then we factorize this side into x, 5, 1, minus, plus. I'm going to put it here. You all understand that step. Now, divide this side by x minus 1. Divide that side by x minus 1. That and that will cancel out. Y equals. We still haven't differentiated. All we're doing is we simplifying. That and that will cancel. We left with x plus 5. Therefore, dy over dx. Now you apply the power rule. After you simplify is equal to, what's the derivative of x? 1. 1 times 1 is 1. X to the power 0 is 1. What's the derivative of a constant? 0. Very good. So your answer is just 1. Your answer there is just 1. Got it right? Nice. Well done. The next one. Try it. Now remember, when you're simplifying it, you're going to still say dx. You're going to leave it in brackets. Only when you're applying the power rule will you say is equal to. Start. Okay, I'm going to do it here on the side. So we're going to say dx 5 over 3. This is x to the half. Will come up to the top as x to the power minus the half. Yes or no? Minus x to the power 1 over 3 plus 2. X to the plus 2 will come up to the top as x to the minus 2. So I'm putting a tick there. Now that we've simplified it, now that we got it in a straight line, now we apply the power rule. So this is equal to. Now you say is equal to. That means now we are applying the power rule. Derivative. So let's do it together. Negative times positive, negative. 5 over 3 times a half is 5 over 6 x. Minus a half minus 1 minus 3 over 2. Agreed? Minus a third is 1. It's 1 over 3 x. 1 over 3 minus 1 minus 2 over 3. Negative times positive is a negative. 2 times 2 is 4 x minus 2 minus 1 minus. Now rewrite your answer with positive powers. You must write your answer with positive exponents. Minus 5 over 6 x to the power 3 over 2 minus 1 over 3 x to the power 2 over 3 minus 4 over x to the power plus. That's your final answer. So first you simplify. First you simplify till you can't simplify it any further. Then you apply the power rule. Then you write your answer with positive powers. Agreed, grade 12? Right, let's give you another one. Give you two more. Two more to do. Two more derivatives. Two more differentiation. Okay. Let's see who's smart in the next two.
Any questions there? I see you guys can smell egg. Something's on the stove there. You frying the brains here, Mr. Kouter?
Bro, this is next level stuff. 3 times the square root of x. Come on, let's make it a stinky problem. Minus 4 over x. And now I'm going to square that. Damn, now that looks rough. Here's two problems to do, 5 marks each. Right, in this one here, I want you to find dy over dx. And here, the question will just say differentiate. Or find the derivative. Answer here, answer there. Let's see who's prepared for prelims already. People are laughing.
Check the comments out. Kouter.
Have mercy on my brain. Let's go. Let's go. Come, guys.
You're asking
Yeah.
for the refund.
Come, guys. People's brains are so here.
But I think Caden's comment is comical. Yo, what was my maths teacher teaching in class?
Ouch.
So look, Mr. Kouter,
Ouch.
jokes aside, this is a reality check.
Yeah.
It's either you're on board or you need to get on board. But the point here is not to embarrass you, but it's a reality check in terms of how prepared are you for your exam.
Absolutely.
There is still hope. So it's not the case where we're getting entertainment value of seeing you fry. Are we correct, Mr. Kouter? Or you see some
Absolutely.
entertainment?
Absolutely. I think many learners here today realize, yo, I thought I was prepared. Okay, now we need to simplify the one on the left. Let me take you out of your misery. How many of you have identified that this is a difference of two squares? Two. Watch here. So y is equal to, we break that up over x to the half minus 1. So that is x to the half minus 1, x to the half plus 1. Difference of two squares. That cancels out. Y equals x to the half plus 1. Therefore, dy over dx. Power rule. Half times 1, half. X. A half minus 1 minus a half. What's the derivative of a constant? So now write it with positive powers, 1 over 2 x to the power half. That's your final answer for the first one.
Just mention it. That's the point.
That's the point. That's why we're here. That's why we're here. Thank you, Emily, online. What a comment.
So Emily says in a comment, let's have a look here. The comments are coming fast.
Nice. Nice. What was the difference of two squares here on the top to simplify?
So what Emily says is, why is Mr. Coates' way of solving these problems much easier? So that's the point to it. It's an understanding and a more efficient
And
way.
just for you guys to see math from a different light, from a different perspective. And I'm hoping that our enthusiasm, our exuberance, I'm teaching you a new word in English. Our exuberance and our enthusiasm about mathematics hopefully will rub off on you. And when you're writing the exam, you'll sit and think, right now, how would Mr. K do it? We were sitting in this workshop. We did something like this. Now, time to dala. Right. Be careful with this next one. Can I erase the one on the left? Who's still writing on the left? Who's taking down corrections on the left? No. Good. One person. All right, I'm erasing. Sorry. We still love you. All right, let's go. dx. 3x to the half minus 4x to the minus 1 all squared. All right, wait. Rather, let's write it like this. Let's put it in brackets. Squared. Now be careful. Guys, you need to pay attention here. dx. You still, guys, I'm not doing rough calculation. Exactly the way I answer it on the screen is exactly the way you can answer it in your paper. This is not rough calculation. It's how we are unpacking the problem. Now put your pens down. We are squaring a binomial. Now this is going to get a bit rough. But if you pay attention, I promise you, you'll get it right. Square the first term. Okay, you know what? Let me make it easier for you. Let's do it this way. Easier for you, let's put it in, let's make big brackets like that. And then let's say 3x to the half minus 4x to the minus 1 into 3x to the half minus 4x to the minus 1. Because if I shortcut way, I think you would have made me explain this about 10 times. Some people, the gradient is a bit steep. All right, let's go. Lovely. Thank you all for the positive comments coming in on the live. You guys are amazing online and working machines. You guys are totally locked in, guys.
So what
Let's
Leighton
go.
says, sir must cover all districts.
Sure.
Sir,
All right, let's go. Right. Foil. First outer inner last. 9x. Half plus half is 1. Right, now be careful. Now let's do, that's my 2 first. My 2 outer terms is minus 12x. We multiplying, base are the same. I add the, so half minus 1 is minus a half. My 2 inner terms, minus 12x to the minus a half. My 2 last terms, plus 16x. Minus 1 is how much? Minus 2. Be careful. Let's collect like terms. 9x minus 12x to the half minus 12x to the half minus 24x to the minus a half plus 16x to the minus 2. So I'm putting it there. We just FOILed it out. We collected our like terms. Can that be my final answer? What does logic tell you? Can that be my final answer? No. I'm going to find my derivative. So now I say this is equal to, now we differentiate each term. Let's all do it together. 1 times 9 is, negative times negative is, 24 divided by 2 is, x, minus a half minus 1 minus 3 over 2. Negative times positive is a, 2 times 16 is, x, minus 2 minus 1 is, minus 3. Can that be my final answer? I just need to write my final answer with positive powers. So this is equal to 9 plus 12 over x to the power 3 over 2 minus 32 over x to the power 3. Here's your final answer. You will get 5 marks for that. Or 6. So we are done with first principles. We're done with differentiation. Equations of tangents now. Equations of tangents. Now, in fact, the one from the prelim paper, let's give you that one. Before we do equations of tangents, let's give you that differentiation from. Check what this one says. If f of x is equal to 3x squared over 2 minus 24 square root x, find f dash 9 for 5 marks. This is the question from the prelim paper. Okay. You want to try it on your own or you want to do it for you? First do f dash x. After you get f dash x, then you do f dash 9. You can't put in 9 into the original. You have to put in 9 into the derivative. So f of x, all right. Let me give you guys 2 minutes to do it. Look, that's all you need. I always say in all my workshops, you take your mark allocation, you divide it by 2 is equal to your time. So 5 divided by 2, you should give yourself 2.5 minutes only to do it. If it's a 6-mark question, 3 minutes. In that way, you will finish 150-mark paper in 75 minutes, 1 hour, 15 minutes. You'll be able to do your paper thrice. When you're done, you don't say you think you got it. You know you got it. Right. So 3 over 2x squared minus 24x to the power half. Therefore, x dash x. 2 times 3 over 2 is 3x. 2 minus 1 is 1. Positive plus negative is negative. 12 times a half, 24 times 12, the half is 12, x to the minus half. Therefore, what you could say is 3x minus 12 over x to the half, which is equal to 3x minus 12 over x to the half is square root x. This is f dash x. But we don't want just f dash. What do we want? F dash 9. Therefore, f dash 9 is equal to 3 into 9, every x, minus 12 over square root 9. 27 minus 12 over 3, 27 minus 4. Your final answer is 23. There we go. 5 marks for that. Please learn. Right. Huh? Which one? Give me an example. Write an example down. This is to the power negative half. So you bring it down to the power. When you bring it, let's just hear. No, you only get rid of the unknown from the denominator, not unknown. Right? All right. Let me explain to you. All right. The question is what happens with this fraction. So have a look at this. If you add f of x is equal to 5 over 3 square root x, right? Only the square root x comes to the top. You keep the 5 over 3. You only get rid of unknowns from a denominator, not the known. So when you simplify this would be f of x is equal to 5 over 3. This would be x to the power a half. But when it comes up to the top, the sign of the power changes. It will become x to the minus a half. Are you with me? Now, f dash x is equal, negative divided by positive is negative, 5 times 1 is 5, 3 times 2 is 6x. Now you minus 1 from the power. Now to write it with positive powers, this must come down again to the denominator. Make sense? Answer your question? Only unknowns get removed from the denominator, not known. Right. Watch this one. Watch this one. A function from the prelim paper here, guys. From the prelim paper. A function g of x. Put this one down. A function g of x is equal to ax squared plus b over x has a minimum value at x equal 4. The function value at x equal 4 is 96. For 6 marks, the last question on this before we get to the cubic graph, calculate the values of a and b. Find the values of A and B for 6 marks. Right. I'm going outside for 2 minutes of fresh air. You will complete this and I will come back and we will mark. I give you 2 minutes. I'm just going for a stretch break. Okay, 3 minutes. Shame, I feel you sorry. 3 minutes. I give you guys 3 minutes to do it. I'm going for an oxygen break.
Learners, just an important note for you that you enjoyed the session. So we really love for you to be part of this. I really hope, as I'm looking at you, that from this cohort today, that you would be one of the victors. So what we do is at the end of the year, in December, we open up a competition called the Awqaf SA Maths Competition. So this maths competition awards cash prizes, 800, 700, 600 odd cash for positions 1, 2, 3, and the most improved learner. So we award cash to the learners that perform well or the most improved in the final examination. Come December, we open up the sport. You don't have to be the smartest kid. You can also be the hardest working kid in terms of your improvement from July to December's examination. So last year, a top learner scored 98%. She's studying medicine at Wits University. In 2022, there was a gentleman, he scored 100% in maths. He's studying at UCT. The most improved learners scored 58% in July, and they scored a 78% in December. So that's what I'm talking about. I can smell a distinction here in this room, and I can definitely smell the most improved. What you say? So ensure you have registered for our workshop.
Okay, we are
Mr.
back. We are back. We are back.
So,
Sound.
Yep.
Give us audio. Custom today. Somebody is on something else, bruh. Okay. Samit, can we get some sound here? Lights, camera, action. Testing, testing. You wanna go pee? Okay. We'll finish this one and we'll give you guys a 10-minute break. Then we come back. Okay, okay. Testing 1, 2. No, I don't have yet. Summit. You, bruh. Okay. All right, let's go. Let's finish this one. We'll give you a 10-minute bathroom break. We'll come back. We'll give you a pee break. And no smoking. It's all in the toilets. Damn. Okay. Okay. Can you guys hear me? Summit. Okay, my brother. All right, we good. Thank you. Settle down, boys. Shh. All right, thank you. Right, let's go. The first thing that we're going to do, g of x is ax squared plus bx to the minus 1. Quiet. Right, the learners on my right here, I need silence. Shh. Guys, we need absolute silence here. Thank you. Right. Now pay attention. Whenever they tell you anything has got a minimum or maximum, derivative must equal to 0. Always. It's a rule. Minimum or maximum, derivative must equal to 0. So let's do the derivative. G dash x. Now wait. They tell you that has got a minimum value at x equal 4. The function value at x equal 4. That means the function value when x is 4 is 96. Shh. Pay attention. So the first thing we're going to do, we're going to plug in the 4 and 96. 96 is equal to a into 4 squared plus b into, in fact, what we could have done, listen, guys, what I would have done now, in fact, let's do this. We could have left it here for now, just for make it easier. Now we just do plug and play. The minute you have a function value of 4 is 96. Where's the point? So we say 96 is equal to a into 4 plus b over 4. Yes or no? Where's the square? Oh yes, square. Thank you. So 96 is equal to 16a plus b over 4. Let's multiply everything by 4. Let's multiply everything by 4. 96 times 4. I'm moving from here to here. 384 is equal to 64a. 16 times 4 is 64a plus b. So basically, 64a plus b is equal to 384. That's equation number 1. Whenever you're solving for a and b, we need 2 equations. Simultaneous. Shh. Now they tell you as a minimum value at x equals 4. So g dash x, the derivative is equal to 2ax. Okay, let's put it like this. ax squared plus bx to the minus 1. G dash x is equal to 2ax minus bx to the minus 2. Power rule. Right. Now for minimum or max, so now let's say g dash 4, it's got a minimum value at x equal 4 is 2a into 4 minus b into 4 to the minus 2 is equal to 0. Why is equal to 0? Because for minimum or maximum, derivative is equal to, because at that point, at your turning point, minimum or maximum on your graph, a straight line got no gradient. That's why for minimum or maximum, the derivative is equal to 0. Now let's solve here. 8a minus b over 16 is equal to 0. 4 to the minus 2 will come down as 4 to the plus 2, which is 16. So let's multiply everything by 16. 8 times 16 is 100. I'm just moving over here to the side. From here, moving to the side. I'm multiplying everything by 16. 128a minus b is equal to 0. That's equation number 2. All we do now, we solve for a and b simultaneously. This is equation number 1. That's equation number 2. This is your function equation. This is your derivative equation for minimum or maximum. Pay attention now. Let's solve for A and B. You can work it out, do your simultaneous equation whichever way you want to. But I already can see something here. I've got 64a plus b equal 384. I got 128a minus b equals 0. I can add the two equations because plus b and minus b will kick each other out. So we add equation number 1 to equation number 2. 128 plus 64. 192a is equal to 384. A equals 384 divided by 192. You get A is equal to 2. We don't think we write, we know we write. When we get perfect values like this as our answer, you know you write. Guys, I'm not working from a memo here. I'm just working with the question paper. I'm doing the memo. We're all doing it together. As if we are writing that prelim paper together. Now let's solve for B. Let's now solve for B. You can now put this 2 here for 64 into 2 plus B is equal to 384. 128 plus B equals 384. B equals 384 minus 128. Here's your final answers coming. Find A and B. B is equal to 384 minus 128. Your final answer is 256. There we go. Beautiful. Guys, you guys are amazing. You guys managed to pull through through all the turbulence today. And I think that many of you did more maths today than you ever did in one day in your bloody lives. I think you all deserve a nice round of applause, guys. You guys are amazing. You guys are absolutely amazing. Let's look at our timing. It's 10 past 2, guys. Please, only 10-minute bathroom break. 10 minutes, we're coming back. We're doing the cubic graph and optimization. Enjoy your break. 10 minutes. 10 minutes only. Minute. 5 minutes to go, guys. 5 minutes. 5 more minutes. And we're back into calculus. I want to finish the graphs and do optimization. I want to finish calculus today. We can start with finance first thing tomorrow morning.
Can you kindly take seats? We are about to start. Mr. Kote is ready to commence with the session. Kindly take your seats. We will start shortly. If you have seen a blue scientific calculator on the floor somewhere in our front rows, it may have been misplaced. So if you do have it in your with you, kindly do turn it. It's on my right and your left. Is someone that has misplaced or lost a scientific calculator. Thank you.
Okay. Sounded, can I get some sound? Sounded, sounded. Oh God. All right, let's go. Sounded. Okay. Right. Let's go, guys. Okay. Okay. The function, I don't know, tell me, f of x equals, Okay, guys. So, pleasure. Okay, Summit. Okay, okay, okay. Let's go. Thank you, guys. That was your 10-minute break. All right. Take this one down. Take this one down. Function f of x. Thank you. Ask him to. Okay. Thank you, great. The function f of x equals x cubed plus nx squared plus bx as a tangent given by g of x equal 2x minus 4 and x equal 1. Find a.
Swami, can we drop the volume? Two down, two down.
Okay, guys. Now, when you see a question like this, I'm giving you a template, I'm giving you a structure. Right. The minute something is a tangent, the two graphs are equal. So, pay attention. Pay attention. So now we need equation. So you do function equal function, gradient equal gradient. Equation number 1, equation number 2. Take that down. I'm showing you exactly how to answer a question like this. Guys, you want to take these notes down, you want to go home, you want to learn this, because these are systems. Okay. Function equal function, f of x is equal to g of x. So let's equate the x cubed plus ax squared plus bx is equal to x minus 4. At the point x equal 1, so 1 cubed plus a into 1 squared plus b into 1 is equal to 2 into 1 minus 4. 1 plus a plus b is equal to 2 minus 4 is minus 2. A plus b minus 2 minus 1 is minus 3. Equation number 1. Function equal function, you equate the two and you substitute x. Straightforward. Little bit down. Swami, can we drop it a little bit? Little more, little more, little more. Right. Thanks. Gradient equal gradient. So the gradient of this, which is f dash x, must equal to the gradient of that, which is 2. Now it's not equal to 0 because they don't say minimum or maximum. Are you listening and listening carefully? We are equating the derivative to the gradient. We are not equating the derivative to 0. We only equate it to 0 when? For minimum or for maximum. Right, let's go. What's f dash x? Derivative 3x squared plus 2ax plus 1 times b is equal to 2. And we got x, which is 1. 3 into 1 squared. They read in the comments and killing themselves here. Right, plus b is equal to 2. 3 plus 2a plus b is equal to 2. 2a plus b equals 2 minus b is minus 1. Game over. Let's solve for a and b. Two equations there. A equals minus 3 minus b. So 2 into minus 3 minus b plus b equals minus 1. Minus 6 minus 2b plus b equals minus 1. Minus b equals minus 1 plus 6 is 5. B is equal to minus 5. A equals minus 3 minus minus 5. A equals minus 3 plus 5. A is equal to 2. And there we go. What are they saying? What are they saying? Are they going crazy? Right, the last one. The last one. The function. No, for which, wait. Find the values of k. Find the value or values of k for which f of x equal x squared minus 2x minus 8 and g of x equals 2x plus k have equal roots. Or let's say you have non-real roots. For 5. We almost there. Guys, you went the entire day. It's the last 50 minutes of the day. Relax, chill, you got this. Before you know it, it's over. It's time to go home. Tomorrow morning we're starting 8:30. Guys, 8:15, 8:15, you guys your registration. We lost time today. 8:30 tomorrow on the dot. Tomorrow is a banger of a day. We have to still do finance and probability and paper 2. Who told you guys not to eat? And he's here. He's sitting here in the crowd. Bruh. Right, let's go. Let me show you how. Right. So all you do is you say x squared minus 2x minus 8 is equal to 2x plus k. You equate the two. Whether they tell you non-real roots, or they tell you real roots, or they tell you equal roots, or they tell you unequal roots. Or they tell you imaginary roots. Non-real is imaginary, like many of your friends. Like, sorry, it just had to come out. Well, we got imaginary friends. Don't you guys have like imaginary friends? I see many of you talking to yourself. And, if you talk to yourself, it's okay. Once you start answering yourself, that you are but khatak. Right. Right, let's go. Non-real is imaginary. Another word for imaginary is complex. So now we need to solve for k. So we say x squared minus 2x minus 8 minus 2x minus k equals 0. X squared minus 4x minus 8 minus k equals 0. That's A, that's B, that whole value is C. Whenever they talk about real, not real, delta, nature of roots. Girls. So now, delta is equal to b squared minus 4ac minus 4 squared minus 4. A is 1, c is minus 8 minus 8. That will give me 16 minus 4 into minus 8 minus k. 16 plus 32 plus 4k. This is equal to 4k plus 48. That's what delta is equal to. For non-real roots, what do we know? Delta must be less than 0. Delta must be negative. For equal roots, delta will be equal. For real roots, greater than or equal to 0. Must I write all those rules down for delta? Or have you? All right, I'll write it down for you after we do this question. So what's delta? 4k plus 48 less than 0. 4k less than minus 48. K less than minus 48 divided by 4 is minus 12. And there we go. That's your final answer. Learn. Nature of roots rules for real roots, real, non-real, equal, unequal, rational, irrational. Right, for real roots, delta must be greater than or equal to 0. Non-real, that we just did now, delta less than 0. Equal roots, delta equal to 0. Unequal, delta just greater than 0. For rational roots, delta must be a perfect square. And irrational, delta not a perfect square. There we go. Take down the nature of roots rules you're going to be using. Part of your toolbox. Ah, 20 minutes left. Sure. Time flies when you're when you're doing maths, no? Time flies when you're in a coma, math coma. Imagine you hate math so much, right? I'm just saying, just think about it. And imagine you die, and God said the only way to go to heaven is get 70% in math. What will you guys say? Send me to hell. Ooh, see how merciful is God. He didn't make you don't need to get a distinction in maths to enter heaven. Right, I'm erasing. Let's go, let's go, let's go. All right. You hear that? Keep us till. Right, you guys want to stay till 4? I'm game. Who's game? I'm game. I'm game. Sir, keep us till 4.
Yeah.
I'm game. Who's game?
There's only a few hands. There's only one hand.
Let's stop.
It's not solar powered. There's only one.
They acting up like our internet. Low blow. So point. All right, let's go. Let's go. Let's go. Right. Quiet. Take this diagram down. Take the diagram down. Take the diagram down. Okay. The following graph is given by f of x is equal to x cubed plus ax squared plus bx plus q. Find a, b, q. Find a, b, q. Okay. Now your x-intercepts are given. Quiet. Quiet. Grade 12. Thank you. Now you know, while you're taking us down, you know you've been taught different formulas for total surface area. Yes or no? I'm going to give you one formula you can use for all shapes. So we're getting there. Huh? Right, thank you. Grade 12. Guys. Thank you. Okay. Now watch here. We're going to go y equals minus into x minus x1 into x minus x2 into x minus x3. It's a negative graph. Remember, a positive graph goes like that. A negative graph goes like that. Thank you. Right. So y equals minus into x plus 2 into x minus 3 into x minus 3. Because it bounces here, you use it twice. Because the graph bounces on 3, you use that x value twice. Now all we do is remove the brackets and collect our like terms. So f of x minus into x plus 2. Let's do that first. X squared minus 3 minus 3 minus 6x plus 9. F of x is equal to minus into first times all x cubed minus 6x squared plus 9x plus 2x squared minus 12x plus 18. F of x is equal to minus into x cubed minus 6 plus 2 minus 4x squared. 9 minus 12 is minus 3x plus 18. F of x, here's your final answer coming up. Minus x cubed plus 4x squared plus 3x plus 18. Now, this wasn't drawn to scale. Otherwise, this last value here, minus 18. Minus 18. Thank you. And that's correct, because that value there is minus 80. Taken from there. Thank you, great Charles. Let's do one more. Let's do one more where your turning point is given. Here your x-intercepts were given. Now your turning point, or what we call stationary points, are given. We almost there. It's quarter to, I think we got, what's the time? It's quarter to, 15 minutes. 15 minutes, pause 15 minutes and we are clear. Don't stress. Right, quiet. This point here is minus 2 and 4. That point there is 6 and minus 8. That point there is minus 1. Right. Quiet. I'll give you a whole set of questions on this. Question number 1. F of x is equal to x cubed plus ax squared plus bx plus c. We want a, b, c. Number 2. For which value or values of x is the graph increasing value or values of x is f of x increasing, f of x decreasing, f of x concave up, and f of x concave down. Quiet. Let's answer the first question. This is going to take us, I think, to the end of today's session. I'll still have to do the optimization first thing in the morning, then we do finance, then I think let's do paper 2. Because we've got lots of, I know probability will be for last. Because it's not so many marks. We lost that whole 2 hours this morning, killed us, destroyed the program, my plan, my action plan, but we'll save it. Let's go. Right. Turning points are given. Turning points are given. So this is where you start. You say f dash x is equal to, now you find the derivative of that. 3x squared plus 2ax plus b. The c will follow it. Right. Cancel out the 2 y's. You won't be using the y's at all. Derivative, we substitute x, not y. Shh. Guys, call this SP1, call this SP2. Equation 1, equation 2, simultaneous equation. And this is maximum and this is minimum. So what do we know? Our derivative is equal to 0. Very good. So let's do SP1. 3 into minus 2 squared plus 2a into minus 2 plus b equals 0. 4 times 3, 12 minus 4a plus b equals 0. Minus 4a plus b equals minus 12. Equation number 1. Let's do equation number 2. 3 into 6 squared plus 2a into 6 plus b equals 0. 36 times 3 is 108 plus 12a plus b equals 0. 12a plus b equal minus 108, equation number 2. So I got minus 4a plus b equal minus 12. I got 12a plus b equal minus 108. I subtract the 2. Why do I subtract? Get rid of the b's. So that sign will change, that sign will change, that sign will change. Minus 4 minus 12 minus 16a minus b plus b minus b is 0. Minus 12 plus 108, 96, I think, yes. A equals 96 over minus 16. A equals minus 6. 6 times 16 is 96, yes. Now let's solve for B. C we already got is minus 1. A we got now is negative 6. We only short of B. Minus 4a plus b equal minus 12. We got a is minus 6. Minus 4 into minus 6 plus b is equal to minus 12. Minus 24 plus b equal minus 12. B equals minus 12 plus 24. 12. Huh? Oh, yes, it's positive. Thank you. That's 24 plus b equal minus 12. B equals minus 12 minus 24 is minus 36. There we go. So now we have an equation. Our equation is f of x is equal to x cubed plus bx squared minus 36x squared. No, no, because plus ax, x cubed plus ax squared minus 6x squared plus bx minus 36x minus 1. Done. Right. Now they ask us for increasing and decreasing. So I want you to write these rules down for increasing, decreasing. Right. Increase or decreasing. We look at the x value of turning point of f, the original graph. Concave up, concave down. What do we look at? The x value of your point of inflection, second derivative. We almost there, guys. We're at the end. I think there's about 6 minutes left. 6 minutes left. Washlan. Right. So they ask you for increasing. Again, tangent. Draw a quick tangent. Draw a quick tangent. Draw a quick tangent. Right. Increase from negative infinite. You can say increasing x less than minus 2. Or you can say from minus infinity up to minus 2. Increasing is also x greater than 6. Or you can say from 6 to positive infinity. Decreasing. It's happening between minus 2 and 6. That's why it's dropping, it's decreasing. X less than 6, greater than minus 2, or minus 2 up to 6. Concave up, concave down. Right. So f dash x will equal to 3x squared minus 12x minus 36. F double dash x will equal to 6x minus 12 equals 0. Second derivative, point of inflection, point of concavity. 6x equal 12, x equal 2. So at x equal 2, that's the point, x equal 2, that's your point of inflection. You can clearly see from 2 going up, smiling face. Concave up is from 2 to positive infinity. Concave down is from minus infinity up to 2. Almost there, almost there, almost there. I just want to introduce you to one of the concepts we're starting off with tomorrow. Another word for first derivative. Pay attention now. Another word for first derivative is speed. And another word for speed is velocity. Why? Those of you doing science, ms to the minus 1. We minus 1 from the power. How do I? This is interval notation. In inequality form, then it will just be x 2 to positive infinity, so x greater than 2, and here x less than 2. Another word for second derivative is concavity. Another word for concavity is point of inflection. Another word for point of inflection is ms second derivative to the minus 2. It's the point of acceleration. That is why science is derived from math. Derivative from math. Speed formula, acceleration formula is a byproduct, is a consequence of derivatives of calculus. Boys and girls, we have come to the end. Lovely, lovely. See you guys tomorrow.
So that's it. That brings us to the end of grade 12. That's paper 1, all the way from South High School. We'll see you tomorrow.